Alright, this is a brief lesson on rationalizing nth root denominators. Okay, we just, in the previous lesson, if you didn't watch it, dealt with nth roots. That means we could have a square root, cube root, fourth root, fifth root, 20th root, whatever n is, n standing for the index. In this lesson now what we have to do is get rid of the radicals in the denominator. Remember, kind of a standard way of writing problems with radicals is to make sure the denominator is rational. That means there can't be a square root, cube root, fourth root in it. So if you look at all the denominators for these three problems, they all have radicals. So let's attack each one separately. And most of us get this one very easily. We go, hey, you got to take it times root 2 over root 2. Remember, that's just equal to a giant 1 right here. And so we're not changing the value when we multiply by 1, but we are changing the way the fraction looks. So on top, that's root 2. On the bottom, root 2 times root 2 is root 4, which is just a 2. And so we've written it as an equivalent expression without the root in the denominator. It is now a rational, just a 2, a rationalized denominator. And a lot of students think that, hey, I'll just always take it times root 2 when I have a problem like this. But you'll notice in the next one, I want cube root of 2 that I have to get rid of. Taking it times a cube root of 2 won't do it. Let me just show you what I mean. If I took it times only a single 2, cube root of a single 2, the denominator, I'm just focusing on that right now, would just be cube root of 4. Well, I can't take the cube root of 4 because I have to have 3 things multiplied together. So it's not going to work very well just taking it times that. So instead of doing that, what I'm going to take it times is the cube root of 2 squared, which is a 4. Okay, so I've written the top as a 4 and the bottom as a 2 squared, but they're both equal to 4. On the numerator, I get the cube root of 4. In the denominator now, I get the cube root of a 2. I've got 2 2's and another 2, so I've got 2 cubed. I get the cube root of 4 over, now I've got a perfect cube, 2, and my denominator is rationalized. And finally, the very last one here, this time I want fourth root. And so you really have to think carefully about what you need to take at times to make it a perfect fourth root. A 4 already has 2 2's in it, so I'm going to take it times another pair of 2's, giving me a total of 4 2's as factors. So I'm going to write it as 4 down here, which is fine. On the top, I get the fourth root of 4. On the bottom, I get the fourth root of 16, which is just a 2. And my denominator is rationalized. So that's the idea, trying to simplify it so we don't have a radical in the denominator. Let's take a look at a tougher one now. Let's put some variables in there. We've got the fourth root of, well, they've got it all under the radical, 2y over 3x squared. You can separate a fraction like this. Fourth root of the top over fourth root of the bottom. Okay? And as I look at it, I go, well, I've got a radical in the bottom, so I'm going to have to take it times the fourth root of something to make it a perfect fourth root. I've got 1 3 down there, so I need 3 more of those to give me a total of 4 3's. I've got an x squared, so I better take it times a couple more x's. Okay, now on the top, I'm going to just evaluate that 3 cubed, 27x cubed. So I end up with the fourth root of 2 times 27, 54, yx cubed, over, it looks to me like I've got 4 3's, so it's a 3, and now I've got 4 x's, so it's an x. Should that x be in absolute values? Somebody might ask that. And I would say, yeah, go ahead and slap it in absolute values. We know it's going to have to be positive, and it better be positive though anyway, because we've got an x cubed up there. And so if x cubed, that's not an x cubed. That's my mistake. Couldn't read my own writing. It's x squared, and x squared. So we definitely better put that x in absolute values. And so there we are with a simplified denominator, or a rationalized rather, denominator. Let's do one more of these guys. Let's do 9 over the 6th root of 3r. Got to take it times the 6th root, now take it times 3 to the 5th, r to the 5th. Giving me a total of 6 3's and 6 r's under my radical. And so my denominator is just going to be 3r now. So I've got 6 3's, so they get to come outside. And I've got 6 r's, so they get to come outside as an r. On top I get 9 times the 6th root of 3 to the 5th power. I'm going to grab my calculator to get a number for that. 243 r to the 5th. Now there's no sense trying to break down 243. I know what it's made up of. It's made up of 5 3's multiplied together, and I have to have 6 of a kind before they can come outside. Don't worry about absolute values on this one because r here at the very beginning had an odd degree. We only worry about it when we got even and even. Even degree, even index. Hopefully that helps you simplify or rationalize your denominators with these nth roots.